Hi guys. We're going to try something new here where I am making this video to explain recursion. I'm braving the weirdness of hearing my own voice in the interest of moving us along a little bit. So I'm going to try to make this as quick as possible. I want to show you a couple examples of recursion through a method that's already done. I'll show you the answers to those two multiple choice questions you did, and then I'm going to set you up with what you need to do in coding that. So starting with this example of a factorial, you probably remember from math class that a factorial is just asking you to multiply a number times everything leading back to 1. So 4 factorial is really just 4 times 3 times 2 times 1. To trace through this, I recommend that you start by writing the original method call at the bottom and building your way up. So factorial 4, if I go into this method, n equaling 1 is my base case, which means that's when I'm going to stop calling the method on itself. Since 4 is not equal to 1, then I'm coming down to this else statement. And so it is asking me to do n times factorial n minus 1. So that really just means 4 times factorial n minus 1 would be 3. And then I'm going to keep calling this method on itself until I hit 1, which is our base case. So this is going to become 3 times factorial 2. And then that would give me 2 times factorial 1. And finally, factorial 1 is actually going to give me that base case where I'm returning 1. But 1 is not my final answer. That is just my stopping state. I now need to send that 1 back where it was called from. So that 1 was from factorial 1. And then 2 times 1, if I do this across, 2 times 1 gives me 2. That answer then needs to go back to where it was called from. And 3 times 2 would be 6. I send that answer back to where it was called from. 4 times 6 is 24. And then that was actually the original method call. So 24 would be my final answer here. So I'm working my way up until I get to my stopping state. And then I'm working my way back down to get to my final answer. Okay, here's another example. It's already done for you, so feel free to pause if you want to take a minute and look through it. But you'll notice it's a really similar process where I started down here with this reverse word. It had asked me to use that as my original parameter. I'm working my way up until I get to my base case, and then I'm collecting those answers back down until I get to my final answer. Next, I want to show you the answers to the two multiple choice questions that you guys looked at last week. So this first one, the answer was D. I think the easiest way to deal with this is if you recognize that x mod 10 always just gives you the last digit of a number. So 1, 2, 3, 4 mod 10 gives you 4. In here, this if statement is, I'm just going to say like it's going to do some stuff. And then the thing that's going to happen after that is it's going to print the last digit again. And so if the last digit was a 4, and then it's going to do some stuff in the middle, and then it's going to print a 4 again. Well, if you look at your multiple choice answers, the only one that starts and ends with a 4 is option D. If you really want to get into the nitty-gritty of what the recursive process is doing, this is calling the method on, it's really just chopping off the last digit. So if you think about 1, 2, 3, 4 divided by 10 in integer division, it would become 1, 2, 3, 0.4, and we'd lose the 0.4. So it would repeat the process with 1, 2, 3, then 1, 2, and then 1. But if you notice, you're always bookending it, like with your last digit. Then you start and end with a 4, and then inside of that would be the 3s, then the 2s, then the 1s. The second multiple choice question you guys had was this one. I think the easiest way to deal with it is if you thought of an actual number to use for m. And so it says k is a non-negative integer, so I'm just going to let k equal 3. And then I'm going to say, okay, well that would make m equal 2 to the power of 3, which is 8. So I'm going to go through this process with mystery 8 and see what gets spit out as my answer. So since 8 is not less than or equal to 1, it's not my base case. So that means I'm doing this recursive step. So I'm going to return 1 plus mystery. N divided by 2 is 8 divided by 2, which is 4. I'm going to repeat that process again. 1 plus mystery 2. And then repeat that process one more time. 1 plus mystery 1. Now, when I call mystery 1, that is my stopping state because n is less than or equal to 1. And I can see that what I'm supposed to return there is just a 0. So if that returns a 0, I can now just work my way back down. So that 0 comes here. 1 plus 0 is 1. That answer comes here. 1 plus 1 is 2. Then 1 plus 2 is 3, which is the answer I was originally asked. So my final answer there was 3. I now just need to connect it back to the m's and k's. I can see that the k value I picked was 3, and the answer I got was 3. And so I know that my answer then for that multiple choice would be B. Okay, one last thing to show you, which is an example in Coding Bat, which is going to help you with your homework. A lot of these questions are giving you some kind of numbers, and you need to respond back with a number. This question is called Bunny Ears 2, and it is telling you that you have this number of bunnies in a line. Odd bunnies, we're going to count that they have 2 ears, and even bunnies, we're going to say have 3 ears, and we basically just need to count up their total number of ears. So the first thing I'm going to do is I'm going to set up my base case first. And so the easiest thing to think about is if I have no bunnies, so if bunnies is 0, then I have no ears, so I can return 0. And I'm going to say no bunnies, no ears. The next thing I should check is if I have an even, so the next thing I'll do is my recursive step. And I'm actually going to need 2 recursive steps, one for an odd bunny, one for an even bunny. So you might remember the way to check odd and even is I can say bunnies mod 2 equals 1. That's saying if it's an odd bunny. And it's telling me the odd bunnies have 2 ears. So I need a way to say add 2 plus all the rest, which means I need to say return 2 plus. Now the way of calculating all the rest recursively is I need to call the method name, so bunny ears 2, and all the rest means just 1 fewer bunnies than I had this time around, so I'm going to say bunnies minus 1. I also want to point out I knew what to call this variable because it's this parameter here. Bunnies is the only variable I have to work with because it was the only parameter. And then the other recursive step is if bunnies mod 2 is equal to 0. So if it's an even bunny, add 3 plus all the rest. So my recursive call can just say return 3 plus bunny ears 2, bunnies minus 1. I'm saying count the 3 for this number of bunny ears, and then this is calling the same process on 1 fewer bunnies. The only issue I'm going to run into when I run this is it's going to get mad. It thinks I'm missing a return statement, basically because I just have a bunch of ifs instead of an else. And so there's 2 easy ways around that. One is to just say like else return 0, which is never actually going to get called, but that will make the compiler happy, so that works. Or the other thing I could have done is I know since this is like my last case scenario, I could just make that say else. And that would work as well. So that's up to you. I think I'll put it back to this. So there you go. That is an example of how this works in Coding Bat. The ones that I'm going to ask you guys to do are listed here. So some digits, bunny ears, and no X. Notice this one is an easier version of the one I just did. I'm hoping we can get through this and then be ready to talk about it next week. Feel free to email me if you have questions. All right, good luck, guys.